here is the actual data NASA kept. They kept track of the damage and the temperature of the O-rings for each shuttle and what each part of the shuttle was. Now, during the testing, Edward Tufte, a statistician, mathematician, not an engineer, he criticized these charts because they're difficult to read and understand. So instead, he created a scatter plot which simply plots the temperature versus the O-ring damage index during launches. So if I make this a little bit bigger, we can see at a temperature of 70 degrees, we had 4 shuttle launches that had a temperature of 70, and they range from 0 to less than 10. Okay, notice even up to 80 degrees, we had a bunch of zeros in there. Just below 70 degrees, we had a bunch of zeros, but then it starts climbing. Notice at about 52 degrees, we had a damage of 20, an index of 20 damage on our O-rings. And they never launched above, it looks like 82, and up until the Challenger disaster, they never launched below 52 degrees. Or they never had takeoff below 52 degrees. Now, question number 2. If you had this data, would you have stopped the launch? Justify your answer using the data. So once again, it's your opinion, but you got to justify it with the data. And question number 3, do you agree with Tufte that in data visualization, simpler is almost always better? Tell me why and address Tufte's charts versus NASA's chart. So I want you to answer that part. On question number 4, here's a theoretical model, and we impose that on the real data. Is the model perfect? And I'm hoping you would answer that one. That part's going to be no. Is it useful, though? And hope you answer that. Now, a little bit more on solving absolute value equations versus just the Challenger. If we look at example 16 here, I want to talk about this one. If I give you an absolute value equation and equals -5, can the magnitude or the distance from 0 be negative? And the answer is no. Distance can't be negative. Since the distance can't be negative, there's no number you can put in for p when you take the absolute value that will give you a -5. So if you ever have an absolute value equation and it equals a negative, we're going to say no solution. And since there's no solution, you can't graph it. So that would just be a no solution. Let's take a look at a example with an application with absolute value where you're going to write the absolute value. It's very similar to what we did with the Challenger. The average temperature in Northern California is 1 degree. So that's what I'm going to subtract 1 from. Okay? Whoops. Didn't mean to cross it out. I wanted to highlight that for you. So we want it to be 1 degree. But it can vary by as much as 5 degrees. So that's how much it can be off by. So write and solve an absolute equation to find the maximum minimum temperature. Now this is a very moderate climate. It's only differs by 5 degrees. So we're going to say x is going to be my variable, or my actual temperature. I'm going to subtract 1 because that's what I want it to be. So if I'm at 1, my difference is going to be 0, but I want my answer to be 5. So in other words, when I look at this, I say, hey, what numbers have an absolute value of 5? Well, that would be 5 or -5. Notice I don't change what's inside the absolute value. I'm going to say what's inside the absolute value could be 5 or it could be -5. So we're going to write 2 equations. We'll say, x minus 1 equals 5, Or x minus 1 could be negative 5. So we add 1 to both sides. And the highest temperature in this Canadian city would be 6 degrees. If I go over on the other one, I would go plus 1 to both sides, and x would be negative 4. So the maximum temperature is 6, and the minimum temperature is negative 4, and I said write the absolute value equation. Now on number 18, we're doing backwards. I gave you the solution. I graphed the solution for you at 6 and negative 4. I want you to write the absolute value. Well, in order to find the absolute value, you got to find the middle. So how do you find the middle of two numbers? Well, the middle two numbers, I'm going to add them up and divide by 2. So I'm going to say negative 4 plus 6. I'm going to divide that by 2. Negative 4 plus 6 is 2. 2 divided by 2 is 1. So right in the middle is 1. Now how far is 1 from either end? Well, notice 1 to 6. That's just like my previous problem, isn't it? I didn't realize that. Is 5. So I'm going to say, oh, the absolute value of x minus 1 equals 5. I didn't mean to make these two examples exactly the same, but it turned out they were, because you're going at 5 in either direction.